Okay, I just want to give you a preview for the free response on this exam 4. You're going to have 4 different problems. Each of them will have 2 to 3 or 1 to 3 embedded problems within each of them. So the first will be a two-ends system. This is probably the easiest of the 4, where you're going to have 2 lenses right here. They're separated by a certain distance. We'll call it X, and I'm going to have an object over here, focal point here and here. And I'll ask you, what is the total magnification? And then also, what is the final image distance? That's going to be Q2. I might also ask you to describe the image. Is it upright, inverted, bigger, smaller? Those sorts of things, which are all based on the magnification. Is it virtual or real, which is based on Q. If Q is positive, it's a real image. So be able to work through that two-lens system. I will not have you deal with a virtual object. We did that in lab, but I'm not going to make you do that in class. All right, the next question that you'll have is going to be a mirror, where you're using the mirror equation. And a couple of things to be prepared for. First of all, I'm not going to tell you what kind of mirror it is. I'm not going to tell you if it's a convex or concave. So you will need to determine what type of mirror it is based on the type of image, how I describe the image. Is the image bigger? Is it smaller? Is it upright, inverted? And so from that information, you should be able to tell if it's a convex or concave. If it's convex, it's going to have a negative focal length. If it's a concave, it's going to have a positive focal length. I'll probably give you the center of curvature, but I won't give you the sign of the focal length, and you'll need to be able to determine that. The other thing is that you'll need to use these two equations, m equals negative q over p, and 1 over f equals 1 over q plus 1 over p. I'm only going to give you 2 of these unknowns. Probably those 2 unknowns are going to be m and f, which means that you'll have to solve this system of equations by solving one of the equations, this one, for one of the variables, say for example q is equal to negative mp, and then putting this into this equation. Maybe not necessarily solving that for q, but that's the process that you go through, is that you solve the magnification equation for one of the variables and then you plug that into the other equation. Okay, so solving a system of 2 equations, and that's really what I'm testing here, is can you solve a system of 2 equations, and then also can you determine the type of mirror from how I describe the image. Okay, so that's, oh, also, I'll have you draw a ray diagram. For either a lens or a mirror. So review those. I'll probably just require you to draw 2 rays and show the image and what the image is like. So for example, if I gave you a convex mirror and I say your object is outside the focal point, you would draw 2 rays. One is parallel to the axis, one is through the focal point, and then the other one you go through the focal point and then parallel to the axis. And then so my image is over here. This is my object, this is my image, that image is inverted and real. Okay, so review your ray diagrams. It will help you with the other parts of the exam anyway. And then the other is going to be diffraction grading. I will ask you how far apart are certain orders on the screen. So with the diffraction grading, here's my diffraction grading, here's my screen. There's going to be 2 steps that you'll need to take. First, more than 2 steps actually. First is determine the slit spacing. So what is D equal to? I'll give you the number of lines per millimeter or centimeter or whatever, and you need to determine D. The second is to determine what is theta. All right, what is the angle theta, say, to the second order bright spot, if that's what I ask you. So find theta, and then the third thing that you'll need to do is determine what is y, where y is this distance. Okay? So, as I said, 1 to 3 questions for each of these topics. And that's all. Yeah, so that's the free response. It would be worth 8 questions overall.